Hello everyone, and welcome to the 7th session of this lecture series entitled EXO in Structural Engineering. In the previous session, we defined the conditional formatting statements for the output parameter destinations in our Excel template up to the ductility parameters C/dt and epsilon t. Today, we will complete the conditional formatting statements and test the resulting Excel template for various scenarios. We will start at the output parameter phi. If we click on it, we can then see the if statement that is assigned to this destination. Here, what we really need to have for the cross-section to be adequate is for phi to be equal to 0.9. So I'm going to show the upper ribbon here and click on the cell that I want to add the conditional formatting to. Click on conditional formatting, new rule. Here I'm going to say use a formula to determine which cells to format. Note that the cell or the destination that I want is already highlighted or selected, and here I can add my condition. I can tell EXO if this destination here is equal to 0.9, then the section is tension controlled and you should show a green color. So I'm going to add here a green fill color. There you go, that's the first condition for this address or destination. Now the other condition for the same destination, I'm going to say here, if this destination is smaller than 0.9, then the Excel template should show an alarming color. I'm just going to choose this one here. Now you may argue that we could formulate this condition in a different way. For example, I can say here that when phi is less than or greater than 0.9, but you know that this condition is not actually a valid one here, because the value for the strength reduction factor phi can be 0.9 or smaller. The limits for the phi parameter are 0.9 for a section that is tension controlled and 0.65 for a section that is compression controlled. So now we have these two conditions, they are ready. Next we're going to go to the destination that shows the result for the nominal moment. You can see that for this particular beam here with these input parameters, this beam is not adequate, so the values that could appear here is either a number which represents the nominal strength or not adequate when the section fails. So I'm going to use that in writing my formatting, conditional formatting statements. So I'm going to come here and say a new rule. If the value in this cell here is equal to not adequate, pay attention that the capital and small letters have to be identical to those that you have used in the if statement for this conditional statement to work. In this case, if the section is not adequate, then just show me an alarming color here. And I'm going to use another conditional formatting statement for the same cell here, but this time I'm going to tell the template when this destination here is anything but not adequate, then show a green color. Why did we use such a syntax? You know that the value that will appear here is either a number, which represents the nominal strength when the section is adequate, or not adequate when the section fails. So I'm going to use these two conditions stated here in the if statement to show the appropriate associated color. So I'm going to click here again and check the conditions for this particular destination. Now, if the value in this destination here is not adequate, you will see a red color. Otherwise, when the value in this destination here is anything but not adequate, which in our case is a number rounded to 2 decimals, if you remember from the previous sessions, then the Excel template should show a green color. The same logic will be applied to calculate the design strength, which is phi times mn. So I'm going to click here and then add a new rule. And here I'm going to state that when the value in this address here is equal to not adequate, then the Excel template should show an alarming color, and the if statement will print not adequate in this destination. The other one, when the section is tension controlled, a new rule, and my statement will be when the value in this destination is anything but not adequate, then the Excel template should show a green color. For the last cell here, note that in the if statement that we have written earlier, we have decided that we will have two outputs. The section could either be tension controlled, or the Excel template should print section failed. So I'm going to use these in my conditional statements. I'm going to come here and say new rule and state that when this destination here is equal to section failed, the template should associate that result with an alarming color. And if the section is tension controlled, then I'm going to state that I'm going to select it again. I'm going to say that when this cell here is equal to tension controlled, the Excel template should associate that result with a green color. Now we can try different scenarios and check our Excel template for correctness. Let's consider the example that I presented in the first session of this lecture series. Here we have a singly reinforced rectangular beam that has a width of 300 millimeters, total depth of 550 millimeters, reinforced with 2 layers of reinforcement. The layer farthest from the neutral axis has 4 bars, 22 millimeters in diameter, and the layer on top of it has 2 bars, 22 millimeters in diameter. The compressive strength of concrete is 28 megapascals, and the yield stress of the steel reinforcement is 420 megapascals. I'm going to go through it here slowly so that you can pause the video at your convenience. We calculated YB, YT, Y bar, then we obtained the effective depth, the reinforcement ratio, compared that to the minimum allowed by the ACI code, then we obtained the depth of the rectangular stress distribution, from which we can calculate the parameter C. The parameter C is used to calculate the ductility ratio C over dt to check whether the section is tension controlled or not. We can either use C over dt or epsilon t for that purpose. Once we decide that the section is tension controlled, we can calculate the nominal strength, multiply it by the strength reduction factor phi to obtain the design strength. In this case, it's 350.24 kilonewton meter. Let's apply these numbers here and check our solution. I'm gonna go here, and this is 300 already. This here should be 550. 420 megapascals for the steel and 28 megapascals for the concrete. Then we have 22 with 22, 4 by 2, everything is okay. So you can see that immediately the Excel template gives you exactly the same result, 350.24. And the section is adequate and tension controlled. Next, I would like to hide the columns and rows that are not used in this Excel template. So I'm going to select this column here, column M. Then I'm going to press on Control and Shift, and at the same time on the right arrow. This will select all the columns to the right of the area where I was working at, and then I'm going to right click and press hide. I will do the same thing here. I'm going to leave this row here and hide everything underneath it. So I'm going to select this row here, do the same thing, press Ctrl Shift and the down arrow this time to select all the cells underneath the area at which I was working, and then I'm going to click on hide again. We can select these empty cells, all of them. The way I'm doing this is you make the first selection and then you press and hold Control down and select the rest of the cells as shown on screen. Once all of these are selected, I'm going to go here and ask Excel to add a white fill to all of them. You remember from previous sessions that this figure can be prepared elsewhere and copied to this template using the copy and paste commands. You can add whatever affiliation you want to add here. I'm going to expand this column a little bit so that it will encompass all the text within the yellow color. I'm going to add the following text here, and I'm going to test different input parameters to study different scenarios. Let's say here that we have 450. You can see immediately that the section is not tension controlled. If we try to reduce the steel reinforcement area by reducing the diameter of bars and the number of bars in each layer, let's try this. Look, if you try to put here 16 millimeter diameter in the layer farthest from the neutral axis while there are 22 millimeter bars in the layer on top of it, you will immediately get a red color indicating that the concentration of the steel should be placed in the layer farthest from the neutral axis. If you put here 14 in the layer on top of it, the red color will go away and the section is tension controlled. Let's try to have 5 bars here and 250 millimeter width in order to provoke the B minimum situation. You can see that the section fails because the width of the beam is not adequate to encompass the steel reinforcement in the layer farthest from the neutral axis, which is 5 bars in this case, whereas if we increase this to 300, the section is tension controlled. Let's try to invoke the AS minimum condition. Let's have the beam a bit bigger, let's say 600, and reduce the diameter of bars to 12 millimeter, which is the minimum allowed. And let's say here we have only 2 bars and 0. You can see immediately that the Excel template tells you that according to the ACI code, this huge section should have a minimum area of steel reinforcement of 544 millimeters square, and what you have is not sufficient to satisfy that. Therefore, AS minimum condition is invoked. If we fix that and add steel, let's say we're going to have 3 by 2, you can see that the section jumps back into the tension controlled zone again. Now you can try at your convenience different beams and check whether the template that you have prepared is actually working correctly or not. Mine is working perfectly so far. I'm gonna call it a day for this session, and hopefully I will see you again in the sessions to come. Best wishes.